CCNA Semester 1, Day 4, Part 2, Subnetting IP Networks. Okay, on this lesson we're going to learn how to subnet IP network. Here I have some subnetting formulas. You have to remember them, you have to write them down somewhere. For to continue in the networking industry, you really need to know these two formulas. For the networks is 2 to the power n, you can see there. For the host is 2 to the power n minus 2. So for network is 2 to the power n. This n will equal how many ones are there? For the host is 2 to the power n minus 2. This n in the host is how many zeros are there. Remember, when we were doing the subnet mask, it was like ones on the left, zeros on the right. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1, 2, 3, 4, 5, 6, 7, 8. Now, here, if you use a formula, for example, you have a 24 ones and 8 zeros. So let's just use the formula for 8 zeros. So hosts, every time you think of the zeros, you are calculating the host. 2 to the power n minus 2. Now this n for the host, because we are looking at the zeros and we have 8 zeros here, will become 8. So 8. And the formula will become like this, similar to saying something like this. 2 times 2 times 2 times 2, 8 times 5, 6, 7, 8. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, sorry, times 2 is 256. So this is 256. We don't forget the minus 2, so it's 254. So with 8 zeros, we can have 254 hosts, because we found that out from the formula. Now what I don't want to do for the networks 24, because that's going to be quite a big number. But anyway, that's the idea. So the networks, we're looking at how many ones are there. For the host, we're looking at how many zeros we have. Okay. Now, say that I have an IP address. You've been given this IP address, 110000.1010.100, like this, and 3, 4, 5, 6, 7, 8.00000. Okay, hopefully you will know that what this IP address is in decimal. If you don't, well, stop the video, start calculating. If you did that, it's 192 this dot 168 dot, all right, dot there, dot 10 dot 0. Okay, now you are given this IP address, this network ID 192.168.10.0 with this subnet mask. Because you're given with this subnet mask, all the ones there are taken. All the ones on the left that we have here are taken. You can't change them. You cannot manipulate the ones. The zeros, on the other hand, are yours. You can do whatever you want with them. You can keep them all together. You can separate them, create extra networks, and so on. If you don't do anything, if you keep it as it is, what you have is one network, one big network. And that network, this network, will have, say, let me just, one second. Okay, we have 254 hosts. If we don't do anything, that's it. One network, 254 hosts inside. All the hosts will be able to communicate with each other without the help of layer 3 device, like a router. Now, if, for example, if you have two departments, we have a financial department maybe, and another department, sales. You want to keep them separate. You want to create extra networks. So sales, they can't just go and look at the financial computers and access them. If they want to access them, they have to go through a layer 3 device, like a router. So for that, you have to separate these 254 addresses. You have to separate these into two networks. But when we separate it into two networks, we don't have any more 254 hosts. We will have bit less. So let's count them. Now to separate them on two networks, first of all, what do we have to do? Well, we have to start borrowing these zeros. We have to change these zeros into ones. Ones, they're already there. We can't touch them. We can't do anything to them. So these zeros, we can manipulate them. So first zero that we have to borrow is this zero here. We can't go and borrow this zero here because the subnet rule says the ones, they have to be on the left and the zeros on the right. You can't mix and match. So that zero is not allowed. The first zero that you can borrow is this. Okay, if we borrow that zero, now the prefix length is going to change. And now it says 25. The reason it's 25 because we have 8 ones, 16 up to here, then 24 up to here, then because we borrowed this bit is 25 now. In decimal is 255.255.255 dot, because this bit here now is representing 128, so that's going to be .128, our subnet mask. Okay, excellent. Now the network formula is 2 to the power n. For the host formula is 2 to the power n minus 2. Because we borrowed one bit, this n will change 1 here now. We can't use these ones. We can't think about them because they're already given to us by somebody else. So we can't change them. But we are thinking about what we did so far. We borrowed one bit. So this n here changed to 1. Now this one is left with the 7 zeros. So this n here changed to 7. 2 to the power of 1 is 2. So if we borrow one bit, we get 2 networks. And each network will have 2. We calculate now how many hosts. 5, 6, 7. So 2 times 2, 7 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So this is 128 minus 2, 126. 126. So yeah, if we borrow one bit, we get 126 hosts per each network. So we will get 2 networks, and each network is going to get 126 hosts. Excellent. The way we did that is to just to find out how many networks we get if we borrow one bit. For example, say that I'm going to use the same. Let's get this. Copy this. Okay. Okay. Change this back to 24. This one to 0. And this one back to 0. Okay, now the requirement is really what are the requirements? Earlier we said, okay, we have a financial and we have sales and so on. Now maybe the requirement is to have 5 networks. We're only worried about networks. We are not thinking about the host at the moment. How many hosts per network? We just want 5 networks. Well, because you want 5 networks, the formula for the networks is 2 to the power n. 2 to the power n. N. Okay, 2 to the power n, and then we have to calculate how many zeros we have to convert or change them into ones to make enough for 5 networks. If we did 1 0, that wasn't enough before. We tried that. So 2 to the power 1, that was equal to this 2. That's not enough. So we're going to borrow another bit. Borrow 2 bits. Here we'll change to 2. So the formula will become 2 times 2, which will be 4. Not enough still. So we need to borrow one more bit. So we borrow one more bit, and the formula here will change 2 to the power 3, which will become like this. 2 times 2 is 4, times 2 is 8. Well, that's good. That's what we need. We need the 5 networks, but the closest we can get is 8 networks. Okay. Now we have, how many ones we have? We have 8, 16, 24, 25, 26, 27. We have 27 ones, so this will change to 27. The subnet will be 255, 255, 255 dot. This won't be 0 anymore. 128 plus 64, it's 192, plus 32 is 224. So 224. Okay, great. Now, we know the subnet mask. For the 5 networks, we're going to borrow 3 bits. We're going to change 3 zeros into 1s. That's going to be our prefix length. That's going to be our subnet mask in decimal, right? And we'll get 8 networks. How many hosts are we going to get? So 2 to the power n minus 2. 2 to the power n minus 2 is, the n will be 5. So 1, 2, 3, 4, 5. So the n will change here to 5 because we have 5 zeros. So the formula will be 2 times 2 times 2 times 2 times 2, 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this will equal to 32 minus 2, we'll have 30. So if we borrow 3 bits, we'll get 8 networks. Each network will have 30 hosts. Done. That is for 5 networks. Okay, later on I'm gonna do a bit more, so let's carry on. So okay, I'm gonna change these back to zeros. 1, 2, 3 /24. This will be 0. Now I need say 15 networks. Somebody comes to you and says, okay, I need 15 networks. So how many zeros I need to borrow to create 15 networks? Okay, well, it's easy. We know the formula for the network, the formula was 2 to the power n. So if you borrow 1 bit, just 1 bit, this will change to 1. And the formula will be 2 to the power 1, which is 2, and it's not enough. So if we borrow 2 bits, this will change to 2, and the formula will become 2 to the power 2 times 2, which is 4, and it's not enough. How about if we borrow 3 bits? Well, earlier we did borrow 3 bits, and the formula will change to this. 2 times 2, 4 times 2 is 8, so this will be 8. That's not enough. If we borrow 4 bits, this formula will change to 4 here. 2 times 2 times 2, add 1 more 2, and this will be 16. Well, that's good. That's the closest. So we have to borrow 4 bits to create 15 networks. Well, in total we'll get 16 networks, but that's as close as we can get. So 4 zeros, I will change them into 1s. 1, 2, 3, 4. Now the prefix length is going to change to /28 because there's 4 extra 1s. And my subnet mask will be 240. So if you borrow 4 bits, the subnet mask will be 255, 255, 255, 240. The prefix length /28, and that will give you 16 networks. Each network, to find out how many hosts we will get for the network, we have to do, well, we have 4 zeros here, so this n will change to 4. So it will be 2 times 2 times 2 times 2, 4 times. So this will be 16 as well. But we have to remember minus 2, then we have 14 hosts. So if you borrow 4 bits, we will get 16 networks. Each network will have 14 hosts. Right. This is the idea if we just borrow, like we are worried about networks only. Not about the host. We will learn a bit later about the hosts. Okay, so I'm going to change this back to 3 zeros, 1, 2, 3, 4/24, and this 0. Okay. When we're doing this, we have to think of something that's called a network ID, then first valid address, last valid address, and broadcast. Okay, we have to give this, each network will have their own network ID, first valid address, last valid address, and broadcast address as well. Okay, so now again, let's do, I want 3 networks. 3 networks. Okay, to have three networks, the formula for the network, the formula was 2 to the power n. For the host, the formula was 2 to the power n minus 2. For three networks, if I borrow 1 bit, this will change to 1, and 2 to the power 1 is 2, so that's not enough. If I borrow 2 bits, change these to 2, the formula will become 2 to the power 2, or in other words, 2 times 2 equals 4. So that's good. We get 4 networks, but 3 we need, 1 may be spare. So we have to put the prefix length will be 4/26. The subnet mask will be 128 plus 64, 192. Okay, so how many hosts per network we're going to get? Well, we have 6 zeros left. So here, this n will change to 6. Or the formula will become 2 times 2 times 2, 3, 4, 5, 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this will be 64 minus 2. This will give us 62 hosts. Okay, excellent. Now I'm going to need to put this down on the, like this, on the network ID, first valid, last valid, and broadcast address. So network ID is to start with the ID that you were given before you started subnetting. So we were given 192.168.10.0. That's the first network ID. First valid address. First valid address will be 192.168.10. Whatever ID is plus 1. So if we add 1 here, it will be 1. 192.168.10.1. Now to find the last valid address and the broadcast address, it's easy if we find the next network ID. Now the first 3 octets, they're going to be the same. So 192.168.10. You have to see where the separation of ones and zeros is. Since it's separating here, on this bit here, now you have to look what that bit represents. This bit is representing 64. So we have to increment by 64 on this octet. So because we have in the last octet the separation of zeros and ones, and this bit is representing 64, so we have to increment by 64 on the 4th octet. There we go, 64. So the broadcast for the first network, for this network, the broadcast address is the next network ID minus 1. So this will be 192.168.10.63. Last valid is the broadcast address minus 1. So 192.168.10.62. Okay. Maybe I'll make it a bit smaller. So that was, you can see the difference. Okay, so the first network is done. That's the ID. That's the first valid address. That is the last valid address, and that's the broadcast address. And we move to the second network. Now, I just want you to remember the first network, the subnet mask, well, for all of them will be the same, but do remember that it's different. It's 192. So whatever IP address you are giving to the PCs, you need to give this subnet mask. You can't give this address because this is network ID. And you can't give this address because this is a broadcast. Now, that's your first valid up to last valid. So different addresses available here you can add. Different type of addresses from 1 up to 62. So 1, 10.1, 10.2, 10.3, 10.4, up to when you reach 10.62. All of them will have the same subnet mask. We move to the next one. Next network is 192.168.10.64. The first valid address is this plus 1. So first valid address will be 192.168.10.65. To find the last valid address and the broadcast, it's easy if you find the next network ID. Now, then, to find the next network ID is we look at, again, where the separation is happening. Since it's happening on the 4th octet, and this bit here on the fourth octet is representing 64, we have to increment by 64. So 192.168.10.64 plus 64 on the fourth octet is 128. So the broadcast is going to be the next network ID minus 1. So the broadcast address will be 192.168.10.127. Last valid is the broadcast address minus 1. So 192.168.10.126. Okay. Okay. Now, second network is done as well. Now we need to remember again, like the first network, the subnet mask is 255.255.255.192. All these IP addresses. Again, this address here is the network ID for the second network. This address here is a broadcast ID for the second network. This is the first valid address, and this is the last valid address. Now all the IPs in the middle are usable. Okay. Now the third network starts with 192.168.10.128. First valid address is the network ID plus 1, which is 192.168.10.129. Again, to find the last valid address and broadcast for the next network, it's easy if we find the network ID of the fourth network, which is going to be 192.168.10. That doesn't change. We were given that, we haven't changed anything there. The only thing we can change is this, the fourth octet. Separation between ones and zeros is happening here, and this bit again is representing 64. So we have to add 64 to the last octet. So this will be 192. Okay, so the broadcast is the next network ID minus 1. So 192.168.10.191. And last valid address is the broadcast minus 1. 192.168.10.190. Again, the subnet mask is the same. Okay, excellent. We found the third network as well. Fourth network is the first valid address is the network ID plus 1. So 192.168.10.193. And to find the last valid again and the broadcast address, it's better if you find the next network ID. So we write down the same, 192.168.10. If we add again 64 to this, we will reach 256. So 192 plus 64 is 256. Now 256 is not allowed, which means that we have reached the limit. We have reached the limit here. So limit is 255. 192.168.10.255, the broadcast, and 192.168.10.254, the last valid address. And they have the same subnet mask as well. Okay, so you just saw how to subnet a small network for three networks only, and we needed 3 networks, but we actually got 4 networks because 2 to the power 2 is 4. It's better to have more than less because less is not enough. So here we have a 4th network separated or subnetted. Okay, next thing, I'm going to take another example, but I'm going to do similar. Now what we're doing at the moment, this is called FLSM, fixed length subnet mask. Now fixed length because all these subnet masks are exactly the same. /26, /26, /26, /26. And each one is giving us 62 hosts. Well, it's really hard to find the network requirements that it needs exactly the same number of hosts per each network. So what we're going to learn later on is something called VLSM, variable length subnet mask. That's more realistic. Each network will have a different requirements based on the host IP address, how many we need. Okay, before we move to that, let's change this back to what it was. So you were given /24, this IP address. Now we don't need 3 networks anymore, so I'm going to change this back to N here. Nothing. The host again, N. Okay, great. Now I'm going to take another example very quickly. So for this example, I'm going to need 8 networks. 8 networks. Networks. Okay. For 8 networks, how many bits do you think we're going to need to borrow? For how many zeros we're going to change into ones? If we change 1, that's going to be giving you only 2 networks. If we convert 2 of the zeros, that's going to give us 4 networks. Sorry, borrow. If we borrow 3 zeros, that's going to give us 8 networks. Okay, so we need to borrow 3 zeros. Let's try that. Let's fill the formula. 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. Okay, excellent. 8 networks. So if we borrow 3 zeros, 1, 2, 3, 1, 2, 3. This prefix length is going to change now, because we had up to here is 24, 25, 26, 27. So there's 27 ones. The subnet mask is changed. 255, 255, 255, and then the last one we have to add. So 128 plus 64, 192, plus 32 is 224, 224. Okay, how many hosts we're going to have for this network? We have 5 zeros left, so we change this n to 5. So the formula will become 2 times 2 times 2 times 2 times 2, 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this will give us 32 minus 2. Each network will give us 30 hosts. Excellent. Okay. Now I'm going to write it down in this. Network ID, first valid, last valid, and broadcast. So the first network ID is what you were given. So you were given 192.168.0. Sorry, 192.168.10.0. So first valid address is the network ID plus 1. Okay, so I'm going to write down .1. To find the last valid address and the broadcast, it's better if you find the next network ID. Now, next network ID, I'm just going to write 192.168.10 because that doesn't change. To find that out, what is the second network ID? It is, if we have to look again, where is separating? They are separating on the 4th octet. So this is the 4th octet. These are the bits are separating. On the left, we have the networks. On the right, we have the hosts. So they're separating here. Then we have to look at this bit, the rightmost bit. What number that represents? That represents 32. So we have to increment by 32 on the 4th octet. So 0 plus 32 is 32. Okay. Now, the last valid and the broadcast we find out for the first network. So the broadcast address is the network ID of the next network minus 1. So 31 on this case. And last valid is the broadcast address minus 1. So 30 on this case. Okay. Now the subnet mask, don't forget the subnet mask is 255, 255, 255, 224. It has changed from 0. Now, we found out the first network is already complete. Now we're going to have 8 networks like this. So the second network, that's the network ID. First valid address is the network ID plus 1, so 33. To find again the last valid and broadcast, it's better if you find the next network ID. Next network ID, again, we're just going to add 32s on each one. So 32 is going to be 64 now. So for the second network, the broadcast is going to be the next network ID minus 1, which is 63. And the last valid will be 62. Okay, that's our second network already complete. So again, that's the subnet mask we have to write. For the first network, we saw that's the network ID. That's the first valid. That's the last valid. So 30 hosts. So write down .2, .3, .4 up to when you reach .30. .31 is the broadcast. For the second network, .32 is the network ID. 33 is the first valid. Last valid is 62. and the broadcast is 63. Okay, now we're just gonna continue this. So 64, the next network, the first valid is gonna be this. So network ID +1, so 65. And to find the last valid in broadcast, it's better if you find the next network ID. We're just gonna add another 32, so it's gonna be 96. And the broadcast is gonna be 95. And the last valid is 94. Done. We found the third network as well. So as you can see, we continue adding, we continue to add 32 in each network ID, and then we do +1, -1, and so on to complete. Okay, now I'm gonna finish just the IDs and then pause the video, and you have to complete the rest of the table. I will complete it as well. When I start the video again, you see the table already completed. Now, that's the fourth network. So the fifth network, I'm just going to continue adding 32. So add 32, that's going to be 112. Sorry, 128. Add another 32, 160. Add another 32, 192. Add another 32, 224. Add another 32 is 256, which is not that. We have reached the limit. So I'll say here the limit. Okay, I'm going to pause the video. You complete the rest of the network. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 networks. And we saw early on, they said we will have 8 networks, and each network will have 30 hosts. Okay, this is a completed table for 8 networks that we did earlier. So what you would do would be like to pause the video and just compare it to your notes. See, everything is exactly the same. Now, next thing we're gonna do, we're gonna learn how to subnet based on the host addresses rather than on the networks. How many networks we need? We are thinking about how many hosts we're gonna need. Okay, so again, I'm gonna grab some of the information here and go to the next page. Here, change some of the stuff here. So this is 23, 24. 0, and now I'm worried about host. Okay, now the requirements, they are a bit different with the host. For example, one network is going to need, say, 50 hosts. The next network is going to need 20 hosts. And next network is going to need 2 hosts. Right, so we actually have 3 networks, but each network requiring different number of hosts. So first one is 50 hosts, second 20, third 2. Okay, so now we have to think how many zeros we have to reserve to have enough hosts. Okay, so we need 50 hosts first. So how many zeros do you think we need to reserve? When you're reserving, we have to think from right to left. How many zeros we reserve? So let's take 3 zeros, for example. So if we try 3, the formula will be 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8. So that's not enough. Way not enough. Okay, let's try again. So 3 zeros is not enough. Let's use 5 zeros. Let's give it 5 zeros. So this formula will become like this, 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 32. That's not enough because we need 50 hosts. So we're going to need to reserve 6 zeros. Let's try that. So again, times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this will give us 64 minus 2 this will give us 62 hosts. So if we reserve 6 zeros, we get 62 hosts. Okay, now I'm going to write down the subnet mask here. So this is for 50 hosts. For 50 hosts, we need to reserve 6 zeros. 1, 2, 3, 4, 5, 6. 2 of the zeros, we convert them, or we borrow them, and we make them ones. Okay, so it's /26. Or I can say subnet mask will be 255.255.255.192. Okay, I need to fix these. 255 here, put them in the middle. 255 and 192. The reason was it's 192 is because 128 plus 64 is 192, the subnet mask. Okay, now this is giving us with the two networks, because we have two ones. So 2 times 2 equals 4. But we are not worried too much about the networks at the moment. So we are only thinking about hosts, because we need 50 hosts, the first network. We are left, or we reserved 6 zeros, and the formula was giving us that we will get 62 hosts with that. So the first network ID is going to be 192.168.10.0. That's what you were given with. So the first valid is 192.168.10.1, because it's a network ID plus 1. To find the last valid and the broadcast, it's easy if we find the next network ID. Next network ID will be 192.168.10. something. This bit is on the fourth octet, and it's representing 64. So we have to increment by 64 on the fourth octet. So this will be 64. So the broadcast for the first network is the next network ID minus 1. So let's write down 192.168.10.63. Last valid is the broadcast minus 1, so 192.168.10.62. Okay, we just found out the first network for 50 hosts. That's the network ID, that's the first valid, that's last valid, and that's broadcast. For the second network, we need 20 hosts. Right, I'm gonna copy this stuff here. So for this 20 hosts, how many zeros are we gonna need? If I just leave 4 zeros, if I reserve 4 zeros, now that's gonna be 4 here. That's not gonna be enough. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 16 minus 2, obviously that will be 14, so that's not enough. So what about if I reserve 5 zeros? I keep 5 zeros. So this will be 5 here, times 2. So this will be 32, minus 2, this will be 30. Okay, that's enough. We need 5 zeros. So this will change to 1 here. This will be 4/27 because we have 27 ones. And this will change to 224. Because 128 plus 64 is 192 plus 32 is 224. Okay, we just found out that we need 5 zeros for the second network to create 20 hosts. Okay, now first valid is the network ID plus 1, so 192.168.10.65. And to find the last valid in the broadcast, it's better if you find the next network ID. Next network ID is 192.168.10. Whatever that bit is representing, we have to increment that octet. So that bit represents 32, so we have to increment 32. So 32 plus 64 is 96. Now the last valid in the broadcast, well, the broadcast is the next network ID plus 1, so 192.168.10.-1 actually, 95. Last valid is the broadcast minus 1, so 192.168.10.94. Okay. Now we just found for the second network as well. For the third network, which we need only 2 hosts, I'll copy this stuff. Now we need only 2 hosts. So if we need 2 hosts only, we can leave only 2 zeros. So the formula will become 1, 2, 3, 4 here. Let's see, 1, 2, 3, 4, 5, 6. Too much. Okay, so for the host, 2 to the power n minus 2. If we leave just 2 zeros, this will be 2. The formula will be 2 times 2, which is 4, minus 2 equals 2 hosts. Okay, so yeah, we need only 2 zeros. This will change to 252, because when you add 128 here, plus 64, plus 32, plus 16, plus 8, plus 4 equals to 252. This you will say /30. So the first network ID, it will be 192.168.10.network ID plus 1 is the first valid address. Yeah, first valid address is 97. Now to find the last valid address and the broadcast, it's better if you find the next network ID. So 192.168.10. And see, this is on 4th octet they separating, and this bit represents 4. So this will be 100 if you add 4 to 96. So this will be, the broadcast address for the third network will be 192.168.10.99, and the last valid 192.168.10.98. Okay, we found the 3 networks. Now, as you can see, there's a different length to subnet mask for each network. Here is /26, here is /27, and on this one is /30. Different length, so variable length subnet mask. Okay, now I'm going to take another example with a class B. I'm going to start. Okay, so now let's use 172.16.0.0/16. Subnet mask for this is /16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm going to convert 172.16.0.0 into decimal. So 172 is 1010. That's 160, 168, 172. Okay, and 16 is 000, 1 for 16, and everything else is 0. Then the rest are all zeros. Okay. Now this subnet mask is /16. So I can say, or I can say /16, or I can say 255.255.0.0. 3 ways of saying the same thing, and it's correct way. Okay, now for this requirement, what we need now is, say the first network needs say 2000 hosts. The second network needs 500 hosts. Third network needs 200 hosts, and the fourth one needs 100 hosts. There we go, 4 networks. First one needs big number, 2000 hosts. Second one needs 500 hosts. Third network, we need 200 hosts, and fourth network, we need 100 hosts. Okay. The formula for the host was 2 to the power n minus 2. Now, 2000 hosts. We have 16 zeros here to play with. The ones we can't touch because ones are not ours. They were given to us. But these zeros are ours. We can do whatever we want with them. We can convert, we can borrow the zeros, make them to ones, and so on. So how many zeros do you think we need for 2000 hosts? Well, if we try 8 zeros, let's try 8. Let's see what happens. 2 times 2, 8 times. 4, 5, 6, 7, 8. 2 times 2 is 4, 8, 16, 32, 64, 1 to 8, 2, 5, 6. Not enough. So how about 10 zeros? If we need to borrow 10 zeros, so I'm going to write that 10 and times 2, that's 10 times. 2 times 2 is 4, 8, 16, 32, 64, 1 to 8, 2, 5, 6, 5, 12, 1024. Now that's not enough. 1000, 2 to the power 10 is 1024. Not enough. So it means just that we have to do 1 more times 2, and that will give us, so 11 zeros. 1 more times 2, and that will be 2048. 2 times 2 is 4, 8, 16, 32, 64, 1 to 8, 2, 5, 6, 5, 12, 1024, and 2048. 2048 minus 2 is 2046. There we go. So to get 2000 host addresses, we needed to borrow 11 bits, 11 zeros. That gave us 2048 minus 2, 2046. Okay, so I'm just gonna take this. And I'm gonna write it. Okay. Now the subnet mask. The subnet mask, because we are reserving 11 zeros, so that's 8, 9, 10, 11. These ones, the rest of the ones, the zeros will become 1. So 1, 2, 3, 4, 5. I'll write them in red as well. That's our subnet. We have reserved 11 zeros. Now it's not /16 anymore, because 16 is up to here. 17, 18, 19, 20, 21. So it's /21. Or it's 255 in decimal, 255. Then when you add 128 plus 64, 192 plus 32, 224 plus 16, 240 plus 8 is 248. So it's 248 here, the subnet mask. Now the network ID is what ID you've been given. So 172.16.0.0. First valid address is the network ID plus 1. So 172.16.0.1. That's the first valid address. To find the last valid address and the broadcast ID, it's better if you find the next network ID. Now next network ID is going to be 172.16. That doesn't change because we had all ones. Now we have to look where the separation is happening. It's happening on a third octet, and this bit represents 8. So we have to increment the third octet by 8. That's the third one, 0 here. So we have to increment that by 8. 8.0. So the last value, or the broadcast I should say first. Let's have a look at the broadcast. Broadcast address is the next network ID minus 1. So the next network ID is this, minus 1. So 172.16. What is minus 1? 7.255. Because 7.255 plus 1 is 8.0. Okay, so last valid address is 172.16.7.254. Okay. Now from 0.1 up to 7.254, there's 2046 different combinations. So 0.1, 0.2, 0.3, 0.4, up to 0.255, then 1.0, 1.1, 1.2, up to 7.254. Okay. Next network. This we need. This will those for 2,000 hosts. Okay. Next one is we're gonna need 1,000 hosts. I'm just gonna copy and paste some stuff. So 1,000 hosts. I'm gonna change this to n. Okay, change this back to 0, 1, 2, 3, 4, 5. Okay. All right. Now, for 1,000 hosts, how many zeros do we need to reserve? So, remember, 8 zeros was 256, then 9 zeros 512, 10 zeros is 1024. Now you have to remember that 2 to the power 10 minus 2 equals 1024 minus 2, 1022. Alright, I just want you to remember that 2 to the power 10 is 1024. Always you can start, like if it's a big number or anything, you can start from that point. So 2 to the power 10 is 1024. So for 1,000 hosts, we're going to need 10 bits. Reserve 10 bits. That's 8, 9, 10. Everything else will become 1. So 1, 2, 3, 4, 5, 6, 7. Oh, sorry, 6. There you go. This is says, or we can say /16, 16, 17, 18, 19, 20, 21, 22, /22. Or we can say 255, 255. Now this will be 252. Right. Okay. Now 2 to the power 10. This will say, copy this bit here. I'll just remove 1. There you go. And this will be 1024 minus 2, 1023. Okay, excellent. So if we need 1,000 hosts, we need to reserve 10 zeros. 2 to the power 10 is 1024, minus 2 is 1022. So the first valid for the second network is going to be 172.16.8.1. To find the last valid and the broadcast, it's better if you find the next network ID. Now next network ID is going to be, we have to look where the zeros and ones are separated. They are separated on the third octet, and this bit here on the third octet is representing 4. So we have to increment by 4 on the third octet. So this will be 12.0. Now the last valid and the broadcast will be the next network ID plus 1. So 172, the broadcast, .16.11.254. 5, sorry. The last valid is 172.16.11.254. Okay. Now we're done for the second network for 1,000 hosts. 1,000 hosts. This one was for 2,000 hosts. Right. Now the next thing we have to think about is 200 hosts. What do we need for 200 hosts? Now I'm gonna just pause. Well, let me just copy this quickly. Yeah, this information here. 3, 4, 5, 6. There we go. 16, 0. Okay. And here. Okay, now it's ready. We need 200 hosts on the third network. So how many zeros are we going to need to reserve for 200 hosts? So if we reserve 8 zeros, that will give us 254. Minus 2, that's enough. So 8 zeros here. Since we are reserving 8 zeros, all these, they will become 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'll write them in red. This will say /24 now, or 255.255.255.0. So 8 zeros, the formula will become 2 times 2, 8 times, yeah, 3, 4, 5, 6, 7, 8. Okay, 2 times 2 is 4, 8 times 2 is 16, 32, 64, 128, 256. So this will be 256 minus 2 is 254. So this will give us 254 hosts, 8 bits. That's enough. We need 200 only, so great. Now the first valid address is the network ID plus 1, so 12.1. Last valid address and broadcast, it's better if you find the next network ID. Next network ID, 192.172.16, I can just write it. Now, the separation is happening on the third octet, between third and fourth. So this bit, it is on the third octet, and it represents 1. So we have to increment still the third octet by 1. So 12.12 plus 1 is 13.0. So the last valid address and broadcast is the next network ID minus 1, yeah? So 172.16.12.255, and last valid address will be 172.16.12.254. Done. So we got 200 hosts as well. And the last we're going to need is 100 hosts. Okay, again, I'm going to copy some of this stuff and put it here. One, 2, 3, 4, 5, 6, 7, 8. Okay. Now what we're going to need, the last one is 100 hosts. So for 100 hosts, if we borrow 7 zeros, that will be enough. So the formula will become 2 times 2, 7 times 3, 4, 5, 6, 7. So 2 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So this is 128 minus 2, we're talking about 126 hosts. That's enough. That's what we need. Okay, so 7 zeros we reserve. The rest will become 1. So here, 1, 2, 3, 4, 5, 6, 7, 8, dot 1. And I'm going to write it in red as well. Okay, this says / now. If you count up to here, it's 16. So 17, 18, 19, 20, 21, 22, 23, 24, 25. So /25. /25 I can say or 255.192. So the first valid is going to be the network ID plus 1, 16.13.1. Last valid in the broadcast is better if you find the next network ID, which is 172.16. Now this separation is happening on the fourth octet, and this bit here represents 128. So I have to increment the fourth octet by 128. So 13.128. Okay, excellent. Now the broadcast is 172.16.13. Sorry, yeah, 13.127. And the last valid is 172.16.13.126. Okay. Now we just have subnetted this addresses. We want 4 different networks. We wanted 2000, 500, 200. Oh, I thought it's 1000. Sorry. Well, I did 500, but I meant to do 1000. Okay, I'll change that to 1000. I wanted to see you to see a bigger numbers, so 1000. Okay, 2000, 1000, then 200, then 100. These are the how do you subnet them. Okay. Okay, so you just learned how to calculate a fixed length subnet mask, and now we did a variable length subnet mask. So you did both sides. I would recommend you to do some training, come up with the numbers like this, and IP addresses, and different requirements, and see how you can subnet it. The idea is the same, what you just saw here. So go through this video a few times, slowly, take notes. You should be fine. Now, one website I would recommend you to visit once you're ready, this one. Go to www.subnettingquestions.com. Here there is tons of questions for you to try and test yourself. So when I was studying for CCNA and move on to CCNP, I used to go to this website and test myself a few times, maybe 2 or 3 times a week and so on. Okay, so first, okay, here there's random, loads of different random questions coming up. Right, so what you want to do is find out the questions, do the answers on paper, and then reveal the answer. So for example, we take few questions here. Let's do the few questions. So what they want to know, first question for example, is what is the last valid host on this subnet network? Okay, so I'm going to put it in my document here. Let's configure it. Let's have a look. Okay, here, question is, what is the last valid host on the sub network? Now, what they want to know is this. Last valid host. What is the last valid host on this sub network? So 192.168.106.96/28. Now /28 is, I'll put 28. 1, 2, 3, 4, 5, 6, 7, 8. Dot. Let's just copy these. That's 24, 25, 26, 27, 28. 1, 2, 3, 4. That's a /28, yeah. Okay. Now /28, I can say 255. Dot 255 dot 255 dot 240. Okay, when this kind of questions comes on, you need to find out what is interesting octet and what is a boring octet. Now boring octets, anything that starts with 0 or 255 is considered a boring octet. Our interesting octet is 240. So fourth octet is interesting for us. Now to find out, we need a magic number. To find that magic number is with all different combinations, which is 256, minus our interesting octet, which is 240. That will give us the magic number. Magic number would be here, on this case, 16. So we know the magic number is 16. So, and it's on the fourth octet. We put 192.168.106.90.0 first, and we're gonna increment every time with our magic number. So keep going, like 0, there will be 16, then 32, then 48, add another 16 to that, what is that, 64, add another 16 to that, 80, then add another 16, 96, add another 16, 112. Okay, now we just found that 96 is somewhere between those two, so both between those two lines. So the first, we found out that there's a 96 112 here. We found the network ID. So the first valid address is going to be 192.168.106.97. the network ID plus 1, and the broadcast is going to be this address minus 1. So 192.168.106.111, And the last valid is going to be the broadcast address minus 1. So 192.168.106.110. Okay. Now the last valid address is going to be 192.168.106.110. Okay, let's get up another questions here. What is the broadcast address of this network? Okay, that's the question. So let me copy this and go to open a new Word document. Margins, use a small one. Okay, what is the broadcast address of this network? Okay, what we need is network ID, first valid address, last valid, and broadcast. Right, these questions, they're asking us about the broadcast address. Now, they already did this for us, so we know these are the boring octets and this is the interesting octet. So what we have to do is find out the magic number. So 256 combination minus our interesting octet, which is 224. That will give us 256 minus 224 is 32. Okay, I'm just gonna not use multiple lines. Okay. Now we know the increments on 32 on that octet, on the fourth octet. So 172.28.163 dot, it's going to be the same one here, dot 0. So these ones are going to increment on 32s and each one. So dot 32, 64, 96, then 32, so 128, 32, 160, 32, 192, and so on. Now we just found out that the range is here. We are looking for this range, so between 160 and 192. So the broadcast address, it will be the next network ID minus 1. So it's going to be 172.28.163.191. That's the answer. Okay, so if we go there, yeah, 172.28.163.191. Okay. Next question is, what is the last valid host address for this subnetwork? Okay, so let's copy that. Right. Okay, what's the last valid address? So what they're looking for is the last valid, this one here, on this network. So here, for example, we have 10.27.224.0 and subnet mask /20, which is 255.255, that's 16. So we are missing 4 bits. So that's going to be 240.0. The interesting octet is 240. If we do 256, which is a different combination, minus our interesting octet of 240, it's going to be 16. 16 is our magic number. Okay, so our network is going to increment on 16s. Now there's quite a lot to up to 224. So if I got 16, then 32, then 48, then 64, and then so on. Now I know at one point is always going to be 192. So if you have anything higher than, for example, 192, 192 will always be there. So I can start from there. 10.27.192.0, and then I can just continue adding 16 to 192. So 10.27, if I add 16 to this, it's going to be 208.0. The next one is 10.27. If I add another 16 to this, it's going to be 224.0. And if I add another 16 to this, it's going to be 240.0. Okay, so now I just found out the range. I found out the next network as well. So, for example, the broadcast address will be 10.27. 10.239.255, and the last valid address will be 10.27.239.254. Okay, so the last valid host address on that subnetwork will be 10.27.239.254. Okay, let's have a look. Yeah, that's fine. That's right. Okay, so what I want you to do in your own time, find out like this, go through the subnetting questions, do some answers. I'm just looking for one more kind of question, and then we will find it, we will complete. All these that I'm skipping, they are the same. So what we did, two or three of them. So here, this kind of questions. How many subnets and hosts per subnet you can get with this network? Okay, so here, let me just copy some of these fonts. Okay, how many subnets and hosts per subnet can you get from this network? Well, the network is 172.26.0.0, and the subnet mask is 255.255.254.0. Okay, so I'm gonna write down 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. That's 255. That's not a 255. That's 254 because that's a 0 there, and that's a 0. Now, first thing you need to do here, you need to find out what class does this address belongs to. And we know the 172 is class B address. So this they were already taken. They didn't do any subnetting there. So what they did, the subnetting, is these ones are here. Now I'm going to write them down in bold and in red. So here you can see they subnetted. So from formula, you have to remember the network formula was 2 to the power n, and the host formula was 2 to the power n minus 2. So for the networks we can have the thing 1 2 3 4 5 6 7. We have 7 ones, and for the host we have 1 2 3 4 5 6 7 8 9 hosts, 9 zeros. Okay, so 2 to the power 7 will become like this. 2 times 2, 7 times 3 4 5 6 7. So 2 times 2, 4, times 2, 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Okay, so this 128. Okay, now for the host, I can use very similar formula. I already have 128 there, so I know this bit is 128 times 2 is 256 times 2 is 512. So this is 512 minus 2 equals to 510 hosts. Okay, so how many subnets and hosts per subnet you can get? Well, we can have 128 subnets or networks, and each subnet will have 510 hosts. Okay, so 128 subnets, and each subnet will have 510 hosts. Excellent. Okay, again, this kind of different question, you just have to try them both. Now, what I want to talk about is it's IPv6 a little bit. Now, think about IPv6. IPv6 had a 2001, for example, DB8 ACAD. And now, when you go and purchase an IPv6 address range, they're usually going to give you like this, /48. This is 48, which means there's 16 bits here, another 16 bits, that's 32, another 16 bits, that's 48 bits. Now from that you can make /64. So here we have 48, you have to make 64. So there's another hex set available for you. 2001 DB8, these are given to you. ACAD. Now there's one more hex set available for you. For example, 000, that's your first hex set, first subnet that you can create, first subnet. And then the next one, it will be 1, next one after that will be 2, and so on. You can continue making different kind of subnets. You have 16 bits available, which is going to give you over 65,000 different kind of subnets for you to be able to do. This is what your ISP sells you. This portion here, the last 16, is for you to be able to create a different subnet. Now the rest is 64-bit. For example, here that you have the rest 64-bit, they are for a host ID. So I can say 000, 000, 000, 000, 001. That's the first host, and so on. Now for some reason, say that you create different subnet. This is subnet number 3. You give it to I don't know, IT department. IT department. Now the IT department, they can take this subnet and say, okay, well, fine, they given to us this, and this is /64. So I'm gonna just format it. Okay, this is by now is 64-bit. So they have another 64-bit for here to be able to create different kind of IP addresses for the department. So what they can do, that's right, 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Okay, here they can have a different IP addresses. So up to here, this is all network ID they've been given to them. This side is for the host, what they can do, but they can use this bit of the host if they want to subnet even further. If they want to create a different subnet, this host, this 0, is 4 bits binary. Yeah, so we have a 4 bits. So let's write. So 1 2 3 4. So you can subnet even further on that bit there, but the subnet mask is not going to be /64, or the prefix length. It's not going to be /64. It's going to be a /68, because you are subnetting there on this one. So the first subnet, for example, will be this. Second subnet, second subnet will be 1. Third subnet will be 10, and the fourth subnet 11, and so on. So you can create quite a lot of subnets, because, well, 15 subnets only on this bit, because if you subnet even further, and you have to remember that this is /68 now, not 64. So by default you can subnet. This ISP just gives you 48 bits. You have 16 bits to create different subnets. If your department takes us one subnet, they can further subnet it into the host portion. So just borrow this 0 or these 4 bits here, borrow this, and then create extra different subnets. Okay, I know it's been a very long video and lots of theory here, but this is subnetting, so you really need to understand it. Do not use any calculator. Everything has to be done on the hand and with the paper, on the head and with the paper. Okay, thank you very much. Thank you for watching, and see you in the future videos. Goodbye.